Hi, welcome back again to my channel. My name is Deva, and today we're going to talk about the Building Machine Learning Products project with the title of Food.com Recipe Recommendation Engine. Alright, what we're going to talk about today is the number one is the problem background, number two is the requirement and constraint analysis, number three is the solution analysis, project plan, and scope of work, and number four is the conclusions and future works. Alright, let's go to the problem background. For those of you who don't know yet what food.com is, it's actually a hub for food lovers. Our revenue comes from ads and selling premium recipes, making user retention crucial. And the challenge, of course, keeping user engaged in a crowded online landscapes. Our project aims to enhance user retention. All right. From those statements, we can say that our problem definitions is that our company needs more users to go into our website. Well, one of the ways that we can do that is by providing them with a personalized service, which means we can actually enhance it with an ML model. Or by this going, we can say that we can try use a recommendation system. And if the user is satisfied, well, maybe user will keep coming back to our website, which means user recurring to use our own website, and which means it's increasing retention rate also equals to greater revenue for us. All right, the business metrics and objective. The first key business metrics for us is the visit number, where the number of customers who visited the website, and the second one is the retention rate, the percentage of customers who continue to use our service or products over a predetermined period, and the primary business objective, of course, build a personalized system where we can enhance consumer experience so that they get personalized recipes that suit their palates. Increase retention rate, of course. Consumers satisfied with recipes recommendation will make them recurring to use our website and increase the chance for a new potential consumers through mouth to mouth. And increase visit number, of course, optimizing revenue by maximizing ad impression and also a higher chance that consumers will buy premium recipes through prolonged user engagement. All right, this is our base model process and notation, and where user actually search for the recipes and they rate the recipes where they can try to make the recipes, and they will try to rate or not rate the recipes. And after that, if the recipes is rated, it will go to our database management and it will consumed by our model, and our model will give the output of the recommended recipes for the users. All right, this is the requirement and constraint analysis. Our primary stakeholders is of course the number one is the users, the platform's primary consumers who contribute and access recipes, driving the core value of food.com, where the objective is they find relevant and high quality recipes easily, benefit from a user friendly and engaging experience. And the second one is the content creator, a highly rated users who create and sell premium recipes, and their objective is gain visibility and revenue for their highly quality recipes, benefit from a streamlined process for content selling. And the last but not least is the advertisers, of course, the entities that display ads to the users on the platform. Their objective is maximize impressions and click-through rates, target ads more effectively to reach potential consumers. The secondary stakeholders of this project is of course, the food.com management, where they oversee the platform's operations, user engagement, and revenue streams. And their objective is increase revenue, of course, user retention, and platform engagement. And the second one is our data science team, responsible for analyzing the user data and providing a solution required to solve the problems. And our objective is improve the solution effectiveness to increase the user engagement and retention, thereby impacting revenue positively. All right, these are the constraints that we identified in this project. The number one is the data constraints, where actually the dataset spans across 18 years, but we limited the dataset to the last 3 years for better relevance and manageability, and lack of real-time data for dynamic personalizations. And the second one is the inventory constraints, where variation of the quality of the user-generated recipes and limited number of premium recipes from highly rated users. And of course, we have human resource constraints with a small data science team and limited expertise in natural language processing and recommendation system. And of course, as all project goes, we have time constraints where short project timeline to show initial results and time sensitive need to implement before key sales or high traffic periods. Well, this is the number three section, solution analysis, project plan, and scope of work. Well, let's say our user journey. Jamie wants to find recipe, food recipe in our website, and he needs to go to our website food.com, and he needs to review all the recipes he wants and choosing one of the recipes. And after that, well, after he chose, he can try to use the recipe and give the rating about the recipe. And after that, he can compare while looking for another recipe, look into other recipe provided by food.com and selecting the other recipe. That's our user journey. All right. Actually, there are so many solutions out there, but here are some of the example of the solutions. Which our solution here is the non-ML solutions, where the number one is the user survey, where we gather feedback from the user on what type of recipe they would like to see more of. And the pros of it, it's a direct input from the users, easy to implement, and the cons, well, it may not reflect long-term preferences. It requires manual analysis. And second one is the editorial curation, where human curated lists and recommendations, where the pros is high quality and tailored experience, of course. And the cons one is the scalability issues and human bias. And the last one is the training recipes, where we can show recipes that are currently popular across the platform, where the process is likely to capture current user interests, and the concepts may not be personalized, and it could be seasonal. All right, these are our main solution here. It's an ML-based recommendation engine with the data, explicit data like the user ID, recipe ID, and ratings. And the algorithm we tried here is the number one is the singular value decomposition or SVD, and the k nearest neighbor or KNN. And well, we utilize a user item matrix, which is a form of collaborative filtering, and the matrix we use to uh, check whether this model is good or not by using the RMSE or root mean square error and MAE, mean absolute error. And of course, we need to maintain our solution. Well, we do continuous monitoring and fine tuning in addition to of new data to keep the model up to date. And of course, the business impact that we hope is personalized user experience leading to increased engagement and potential revenue streams. Here are the project plans. And of course, the number one is we are going to make the pipeline for data collection and pre-processing, where we gather historical user interactions and relevant metadata. And the exploratory data analysis, where we understand patterns and statistics to guide the modeling process. And of course, the number three is the implementing and fine-tuning the SVD and KNN's algorithm. And after that, we can go to the evaluation where we use LMSE and MAE to measure model effectiveness. And the last but not least is deployment and implementing the model into the containerized API. And whether if we want to update the data, we can always go back to our pipeline in the data for collecting and preprocessing. All right, this is our scope of work where we have three things, the three separate things we can see. Where the must-have section is that the data collection and pre-processing pipeline, and model outperforms baseline metrics in RMSE and or MAE, and a user-friendly front end. Well, the other one is the nice to have one. Is the we It's nice to have a real-time update capabilities and additional features like recipe, search, and categorization. And the one that we are not covered in this project are the mobile app development and the real-time chat or community features. All right, these are our data sets where we split the data set into 70% and then for train set and 30% for test set. All right, these are the exploratory data analysis where the most common words and ingredients. This is a word cloud visualization reveals that the most frequent words in the recipe ingredients are baking powder, black pepper, olive oil, and flour. That suggests that majority of the recipes are centered around these key ingredients. And the second one is the rating distribution. The rating distribution displays a skewed pattern towards the rating of 5 and 0. This is indicative of a user behavior where people are more likely to rate recipes they absolutely love and refrain from rating recipes they do not like. Alright, the last one is the top 10 most rated recipes. Among the top rated recipes, best banana bread stand out the most popular. This aligns with the observation about baking powder being one of the most common ingredients and indicating that a strong user preferences for bread and baked goods. Other highly rated recipes in the top 10 list include cookies, waffle, pancakes, and cupcakes. Well, the methodology we use here is the first one is the visual engineering with user item metrics. Why we use user item metrics? Well, it's direct. We can directly use the rating data and the algorithm KNN. And why we use KNN? Because it's simple, flexible, and easy to interpret. And the metrics we use RMSE, and MAE, like I said before, because it's well, while RMSE is sensitive to large error and MAE is easy to interpret and less sensitive to outliers. And if you want to know more about the user item metrics, what is it? The user item metrics is a two-dimensional grid where rows represent the users and the column represents the items, in our case, recipes. Intersecting cells contain user ratings. And why it's important? The metrics serve as the foundational data structure for our recommendation algorithm, allowing for efficiency, similarity calculation. And what about KNN? KNN is a type of instance-based learning that identifies k closest points or neighbors to a given data points. How it works? KNN uses similarity measures to find these neighbors and make prediction based on their attributes. In our case, it identifies the user with similar tastes, profile to make recipes recommendation. All right, these are our methodology. Cost and similarity. What is cost and similarity? Well, cost and similarity is a metric used to measure how similar two factors are regardless of their size. It calculates the cosine of the angle between these factors. Why is it useful? In our user item matrix, each user can or item can be considered as factor. Cosine similarity help us quickly identify which factor as are most similar, thereby facilitating efficient and accurate recommendations. The metrics to evaluate the performance of our model, we use two key metrics: error with mean square error. The metric give us the square root of the average of the squares of all errors, and the MA, mean absolute error. This measures the average magnitude of the errors between predicted and observed values. This is the results of our modeling, and this is the model comparison, where the summary is the Canon model outperformed the SVD model in terms of RMSE and MAE, with Canon yielding an RMSE of 4.069 and SVD an RMSE of 4.686, and with means the impact, the lower error metrics indicate a more accurate predictive capability, enhancing user engagement and retention. This is one of the SVD error metrics that we see. What is so? This graph demonstrates how the error metrics for SVD vary between different value of k or number of latent factor, where we can see the takeaway from it. Although the error reduces up to a certain point, it starts increasing after that in the test set, and getting an optimal number for latent factor. Latent factor here. And this one is the Canon error matrix. What does it show? This graph illustrates how the error matrix for Canon changes with varying numbers of neighbors, where the takeaway is the matrix stabilizes after a certain number of neighbors, indicating an optimal value for accurate predictions. And this is the front end dashboard for our website, and we can see that the administrator of the users, the administrator of the website can see the user selections. A drop-down list allows admin to select the user ID and view recommendations accordingly. This feature is crucial for demonstrating the system's capabilities. And the past rated recipes, a dedicated column, shows recipes that the user has previously rated. uh, these past interactions data serve as an essential input to our recommendation engine. Personalized recommendations, of course, another column displays personalized recipe recommendation tailored for the users. And these recommendations are generated by the model to serve and engage the user more actively. All right, now the conclusions and future works. The conclusion is we made a personalized recommendations aim to boost user engagement and retention by providing tailored recipe suggestions. Dataset utilizing food.com data from the last 3 years, constrained by computational resources. Algorithm selection, we compared SPD and KNNs, opting for KNN due to superior RMSE performance. User item metrics, where we built on explicit iteration without additional hyperparameter tuning. And admin insights, the system serves both end users and administrators, offering valuable insights into user behaviors. Containerization, both front end and back end are containerized using Docker for scalability and maintainability. Of course, the last but not least is the promising KPIs, where we hold the potential to significantly improve the user retention and repeat visitor rate. These are the future works that we can do. The first one is the expand dataset that we can try to include more years as computational resources become more available. Personalized features aim to incorporate implicit data like browsing history or even more personalized recommendations. An advanced model results into more sophisticated algorithm to improve recommendation quality. User interface, of course, optimizing existing UI to display recommendations directly on the user accounts. And admin UI, improve the administrative interface for better monitoring of user behavior and recommendations. And the last but not least is the Docker optimization. Fine-tune Docker setup for better resource utilization and faster startup times. All right, these are our teams. You can connect with us on LinkedIn. Here, yeah. And thanks. If you have any questions, you can comment down below or go to my GitHub page here or LinkedIn. We can connect to each other. All right. Thank you. See you next time.